So here you have 20 spaces to work with. You can just write anything. Spaces are taken into account here. So this is what you input it, and then this is the C out. So for this, you want to use cin.get, and then this line right here. You can't just use regular cin like with the integer. It just doesn't work that way. So moving on to strings. Uh, so in C++, string objects, they hold they're strings, kind of like characters, but like the character arrays, but not really. Here you're able to put as much information as you want into the strings. You can like when you have your user input. So an example of a string is, so first you would write string, and then let's go with string A. And if you wanted to know the size of the string, instead of using size of like the character array, use the name of the string and the length. So my string is A, so A dot length, and then parentheses. So as you see, we get 0 because A doesn't really have anything. We were to put A is equal to, and uh, just any name. Or actually, let's put hello. And then you were to see out the size of that. As well as what string A is now. So here we have 0, which is this first C out, um, which it was 0 over here. Because the string A has nothing inside of it, and then we changed after this line. We changed A to have hello, and here, as you can see here, it has 5. Unlike the character arrays, which previously had 6, that's because the string doesn't have any null characters that are taken into account. So this is just the amount, the length of what the word is. To input a string, you would want to use get line and then cin and then the name of the string. You cannot use just cin like an integer. This, like the character array, it's a bit different. So if you had string A, and then let's go with enter a string, so you know that you want to put a string there. You're going to put get line parentheses, you're going to put cin comma and the name of your string, so mine is A, and then you can put cout, this is what you entered, and then just the name of your string. So if we run that, enter a string. So just put hello world. You can just keep typing on this. So as you can see, so this is the string we entered, and then it repeats like it should, because that is now what is in A, or string A. Moving on to pointers. Pointers in C++, they hold the address of a variable. So the way this can be seen is using the ampersand. Using this, with this, you can see the address that a variable holds. And there's also this dereference operator. This points to the value that is inside of the address of a variable. So a way to see this would be if we had integer a is equal to 7, and we were to see out, and then we use the ampersand sign, and then a. Let me just clear this, it'd be better. So you want to. So here you go. You see this this line right here. This is the address of A. So inside of this address, it is holding the value of 7 that we assigned to it. Oh, that was the same. So this dereference operator, this star, this is what helps point to the value inside of the address. So how you would write it would be integer and then PTR would be the address of A. So what this means is, so since PTR, this right here, this is short for pointer. This is pointing to the address of A, but this dereference operator, it points to the value that is inside of A. So just to show that these two, the PTR and the ampersand and A, since this is going to be the same thing. Since PTR is the address, this is going to show the same. So as you can see here, this first line is from address A, and then this second line is PTR, and they're the same. But if we were to change this to have the dereference operator, so now since PTR is the address of A, this dereference operator points to the value that is at that address. So now if we run that code, so here we get the address, and then here we get the value that is inside of that address. So we get this value because of this dereference operator. So now we have call by value. This is used by having functions that are called inside of the main function, and they have the same parameter. In these functions, or in this type of situation where you use call by value, the main the original value is not changed. What I mean by this is let me show an example. So let's go with integer a is equal to 5, and we're just gonna output that value. First let's make a function. So here we have function 1. The parameter is an integer. Because this is the return type. You want it has to have a return value. Okay, so just continuing with this. Okay, so what this does, okay, so in this call by value example, here we have an integer a, which is 5, so we're gonna output 5 because of this line, and then when we go to this line and we call on function 1, we pass the value of a to this function, and here we have, in this line we have a is equal to a plus 1, so um, this is 5 plus 1, which is now 6, so we're going to return 6. But this value of a right here, this is not going to be 6. This is still going to be 5. So let me just show you. Okay, so here we have 5, which is from this line right here. And then when we have cout, that's these two lines right here. Because when we cout, we output whatever is inside of this function. So since we have to output this line, the address of a in function 1, and then we have the address, and then we have here we have 6, because this is the value of a we're returning in this function, not from the main function. And here we have 5, which is this line right here. So the reason that these are different is because the addresses within the main function and function 1, they are completely different. They're not the same. So let me just show you. So this will be address of a in main function. So if we were to run this,